Hello and welcome to Petrosys webinar series. My name's Jason Dixon. I'm the training coordinator here at Petrosys, and in this webinar we'll be running through the Probabilistic Resource Calculator. So I'll be running through an introduction to this new functionality that we've released in Petrosys. So I will run through the agenda. I'll run through an introduction. What is the PRC? What do we use it for? And what is it all about? We'll have a look at the input parameters that we need to use to generate our resource. The output parameters that are generated, what we can use those for, and also I'll run through a demonstration on how we actually use that. After the demonstration, I'll run through some final thoughts. So the introduction. Petrosys allows users to generate a probabilistic range of resources. Previously, this was only allowed within the PLDB functionality add-on for Petrosys, and now I've added that into Probabilistic Resource Calculator. So the PRC, this allows the users to quickly and easily generate a probabilistic range of resources based on the geological distributions as inputs. So any of our users that have the Volumetrics and a DAC Connect license can now use this. So various distribution types such as log normal, normal, stretch beta and triangular can all be used in the Probabilistic Resource Calculator, and we can generate resources for oil with associated gas and gas volumetric ranges. And to these ranges we can also apply risking, so we can generate our risked resources. So our input parameters. These are used to determine the output resource range, and the input parameters include the bulk rock volume, or GRV, or depth area constant thickness, or the depth area pairs. We can also use porosity, hydrocarbon saturation, the fluid factors such as BO and shrinkage, the degree of fill of the reservoir, the net to gross of the sand shale that we expect to see in the reservoir. We can also apply recovery factors and probability factors such as the probability of reservoir, the probability of charge, and things like that. So once we've input all of those parameters, we can generate a standard HTML report for the low and the high side case for the gross rock volumes. We can the outputs from the PRC include our distributions for the oil and gas in place, our untruncated risked and unrisked recoverable resource. This can be done for oil, so recoverable oil and associated gas for both untruncated, unrisked and risked. And also for gas, raw gas and associated gas such as ethane and LPG, again for both untruncated, unrisked and risked. And these can then be exported to a CSV format, which we can then use in other platforms, such as importing directly into the Petrosys PLDB database, which is a prospects and leads database. So now I shall run through a demonstration on how this all works. So here I have a structure which I've used our LCC, or lowest closing contour, to generate a series of structural closures for. So we've had a previous webinar on LCC, so you can go back and have a look at that one if you're not sure how this works. So I have my lowest closing contour, which is being generated into a shapefile, and it has a polygon number 18, and this has a depth of minus 1438.72 sub C. And then I have an upper level which is going to be LCC number 6, and this is minus 1364.79. So I can then use those shapefiles and open up, so we can open up the surface modeling module, which will open up this window here, and then from volumetrics we can now select the Probabilistic Resource Calculator, and this was released in 2018.2. So once we've opened up the Probabilistic Resource Calculator, we then have a panel such as this, which is very similar to our old volumetrics panel, but now we have a high and low percentile that we can add in. So we can select our gross rock volume method, and I'll run through each of these, but to start off we have with the GRV method. We also have the depth volume and a depth area constant thickness. We can run log normal, normal, stretch beta or triangular distribution types on these. And we need to select whether our grid is positive up or positive down. This instance it's negative sub C, so it's positive up. And then we select whether we want to use a top or a top and base grid, and the hydrocarbon type, whether that be oil, gas or oil and gas. Down the bottom, this panel is the same as we have in the previous volumetrics panel. We can select our slice thickness, which doesn't have any impact on the volumetric produced. It only has an impact on how often we report those volumes, so how often we generate a slice thickness and report volumes on those. We can then define the cell refinement and do a cell refinement near polygon edges as well. And also we'll select whether we want to run it metric, feet, yards, and our output units, whether they're metric or imperial. What is new is these two percentile tabs, the high and low percentile. So we can select what percentile we want to use. We have a selection here that we can fill in. Select the grid that we want to use. So the grid that I showed you before is our Hutton grid. And then we can select the level. So at this grid, the top of the structure is approximately minus 1280 meters subsea, and the oil water contact for our low percentile is minus 1364. And then we can select the polygon for that, so that's LCC number 6 for our low percentile. Again, we do the same for our high percentile, select our levels and our polygons. In this instance, I've selected LCC number 18, and the same, and then make sure that we select the percentile that we want to use, whether that is P10, P50 or so forth. Under the Reports tab, we can still generate all of the same reports as we have in the past. So we can tick on the Generate Reports and then select which reports you want to do. So I'm only going to run a report for the GRV method here, just to show you how that works. So we have an XML report, and I can tick on View Report, so that'll pop up when we run that report. And again, we can also generate charts and edit the chart axes. So what I'll do now is I'll just run that individual task, and we can see how that works. So first of all, it'll generate the volumetrics for that. So it's generated the P90, which is our low percentile, and in the background it's also generating our P10, our high percentile. So we still have our volumetric charts and reports for each of those, the gross rock volumes here. We can see that we have our distribution type along the side. We can see that we've got the top and the base, the area and the volume slices associated with those. We have that for the high and low. The other thing that pops up is this panel here, which is our Probabilistic Resource Calculator panel. So when we first open it, it asks us to please enter the required values for our geology and tells us what we need to do. So we need to press the compute button to calculate that and then export it to Excel. So I'll just close that now, and you can see that the GRV that we've generated previously in those XML reports has automatically been filled into this report here. And you can see here I've got the log normal. I can also change the distribution types for each of my different inputs. So this is the geology tab to start with, so we can enter in some distributions for our geology. So we'll start off with 18% for our low side, and you see when I click over here, it automatically throws up an error saying that your distribution's out of the range. It needs to be between 0 and 1, and it's gone up to 2. So if I type in here 0.22 for 22%, that error message goes away, and you can see we now have a distribution. So the degree of fill, I'll leave that the same. Our net to gross, I'll put in some values there to generate a distribution. And again, you'll see that error messages pop up until we have the distribution within our window. At any point here, we can click on this little cog and look at the plot distribution, and it shows us how that plot looks. And we can close that, we can save that or zoom in as well. And we'll also need to fill out our oil, so we can fill out our saturation of hydrocarbon to be between, say, 0.6 and 0.8. We'll leave BO as 1, and our recovery factor we can put in 18 to, say 25%. And now when I click on the Compute Results tab, that is generating our probabilistic distribution. So when I click on the results oil, we can see now that we have an oil in place distribution, and we have a recoverable oil distribution, which is at this point in time is the same as our risked untruncated, because we haven't applied any risking to that. So if I click on the plot here, distribution, we can see now I have a distribution for my volumetrics recoverable resource. So we can go back now and have a look at our probability factors, and I can put in the structure and trap percentage. We've got a pretty good confidence in our structure. We can put in 0.9 for that. Closures 0.9, reservoir may chance of silting out, and our seal we have pretty good confidence in that, and our charge bit lower confidence. So now you can see that we've got a 35% confidence into distribution. So click on Compute Results, look at our results oil, and now we have a risked distribution as well. If I wanted to, I could also go in and put in a gas oil ratio and associated shrinkage gas factors, and just put in distributions for those. And we can also put in correlations. So if our gross rock volume and net to gross, we can put in 1 to 1 at the moment. We can change that distribution, and they can put a dependence between one and the other. What we'll have a look at now is the depth volume pairs. So this is similar again. We have our same at the top, same compute tab is the same, our low percentile tabs are the same, but now we can put in our spill point. So what I've done is I've put in a spill point for our low and high side, so the polygon, the grids are the same, but I've just put in our spill point. So if I cancel that and just run that individual task, you will now see that when that pops up, this time I haven't run a HTML report, it's just going to pop up straight away with the PRC window. So the PRC window will now appear. Our message that tells us what we need to do will pop up, so we can close that off. And once that's loaded data, we can close it off. And again, you can see that our range has been put in. I can click on the depth volume tab, and you can see that we have our depth volume pairs. And they go down, and we can see that once our low side reaches our spill point, it goes to 0. So again, we can fill out the geology tab for those as well. We can click on the profile chart there, and you can see that we have our volume min-max and our spill point min-max. So you can see that our volume minimum for the low side and volume minimum for the high side continues down. And again, we can fill out our oil, porosity and those factors and come up with a similar result. The last one that I'll show you is the depth area pairs. So I'll open this one up again. Again, this time we don't have all of the other charts. The compute tab again is the same. We have our low and high percentile. We again can select our polygons for our low and high percentiles, but this time, as well as a spill point, we need to put in a gross interval thickness. So we do that for our low and our high, so the difference between our crest and our spill point. I've typed in the gross interval thickness for that here. We click OK to that, and we can run that one. And this time we will have a similar chart, but we will see that those thicknesses have been pulled through, and the charts are a little bit different when we look at those charts. So you can see it doesn't take very long at all. It runs on a secure server in Petrosys offices, so that's secure, only you and the server can read that. And again, window pops up, our gross interval has been populated, our contacts have been filled in. If we click on top structure depth area, again those values are all filled out, so we can read off our depth area pairs from there. And if we look at our profile chart, we have our spill points and we have our top and bases for our high and low. So if we fill out some geology parameters this time, so porosity, we'll fill out those, and net to gross, we'll fill some of those out as well. And then if we compute those results, we can then go to the results all tab. We have a distribution here. If we go to oil, we can fill in some other factors, so a saturation of hydrocarbon, we'll put some values in for there. And we'll put some recovery factors in. And we'll leave the gases alone, and we can put in some probability factors here. So let's put in 0.6. Just any values will do, just for a demonstration. And we'll compute those results. So we can then look at those results for the oil, and we see we've got a nice distribution here. We can click on the cog, plot that distribution and see how those look. So we can see we've got a nice probabilistic distribution. Close it off, and now we can export those to our CSV. So that's been exported. We can open that up, which has just popped open in another window. So now we can see here that we have our depth area pairs. Look at the depth, we've got the minimum distribution types. We can look at our inputs, they've all been saved for us, so we can go back and compare their inputs. We can export those to another thing. We can pop them straight into reports, and we can see the results as well. So we have our results here. We can then display these directly onto the map if we wanted to as well. And we have our PLDB import page. So this is if we wanted to import it into a prospects and leads database. We click on this chart here to import this chart. So I hope that was useful for you. If you have any questions, please hold to the end and I will go through those. But at the moment, we'll just run through a few more flower point slides. So we've run the demo. So now we'll go through the final thoughts. So the LCC features allows us to quickly generate our structural closures, and we can use those in the probabilistic resource tool to generate a probabilistic distribution. So the risk distributions can also be generated, and oil and gas types can be used as well. So we can use oil and gas, or gas. And we have multiple types of distributions such as log normal, normal, stretch beta, and triangular that can all be used. And we can use those on the input values, and also once we're into PRC we can select which distribution type we want to use for each of our inputs. And we can then output those to a CSV file which we can export into other formats and other tools that we need to use. So if you want to have any more information about this in Petrosys, this webinar will be uploaded to the Petrosys portal and to our Petrosys website, so that you can look under there under the Learn tab. So if you click on the Learn tab under the Petrosys portal, you'll be able to find these presentations. If you want to learn anything more about volumetrics in Petrosys, we have how-to documents under the Petrosys portal. So if you click on the Learn tab, type in volume into the search field, you have this list of volumetric tools that you'll be able to use. You have videos, workflows, and so forth that will help you run volumetric assessments. And also, if you want to run through some Petrosys training courses, we do have an Accountable Volumes course, which is a half-day course. If you contact the Petrosys training coordinators in your region, they'll be able to help you get onto one of those courses. So if you have any questions, please ask them now, and I hope that was beneficial for you. Thanks for your time.